Okay, we're going to go through polynomial functions. So today what we're going to do is look at what each one is and look at sort of patterns and things that happen with each of the different types. So the first one we're going to look at is a constant polynomial function. So what that is, that's when we have an equation that's just simply like y equals 5. So if we were to draw the graph for that, all we'd get is a straight horizontal line going through y equals 5. Okay, so the key thing you want to be aware of when you're doing these constant graphs is they're always just going to be a flat horizontal line. So if we did something like y equals -3, it would be same thing, a horizontal line, but it'd be going down through -3 this time. Okay, so let's go through each of the things. Because there's no x involved, we would say it has a degree of 0. So when we do degree of an equation, it's based on the exponent of the x. If we had x squared, it would have a second degree. X cubed, third degree. But in this case, because we have no x, there's actually, we could consider it being like 5x to the 0. So that means we'd have a 0 degree for a constant function. The next thing we want to look at is the domain and the range. So when we have a constant function horizontally, all possible x values are on the graph because it goes on and on forever in both directions. And in this case, the range is just y equals 5. We don't have any kind of variance in the y. So y is always going to be 5 in this case. X-intercepts. For a constant function, we normally have none. There's only one case where the x-intercepts wouldn't be none, and that's if the line was y equals 0, which would be right on the x-axis. Then in that case, we'd have an infinite number. But normally we have none. And the y-intercepts, we have 1, and in this case it is at y equals 5. And turning points is like a maximum and minimum, so in this case we have none. And end behavior, we would say it is, basically what we're looking at is how does the graph go between quadrants. So in this case they're either both up or both down. So what that means is if you look at the two graphs, both ends are in the top part of the quadrants, 1 and 2. Remember the quadrants go a number like that, so 1 and 2, or they're both in the bottom at 3 and 4. And that's it for a constant graph. So it's pretty straightforward, nothing too complicated. Okay, let's do the same thing for a linear graph now. So a linear graph, it's an equation something like 3x plus 2. So if we were to graph that, we would basically get a straight line, but this time it'll be diagonal, and it would look something like that, where it's going to cross at the point 2. Okay, so let's go through the same types of things again. In this case, the degree, we say it is a first degree because on the x, we could actually have an x to the 1. So we would say it has degree 1. Okay, then we'll have domain and range again. And once again, these things, because it goes on and on forever in both directions, but now it goes on and forever directions horizontally and vertically. So that means both the domain and the range will be any real number. X-intercepts, we have 1. In this case, we could actually solve for it, or you could use your calculator to find that x-intercept location, but we don't need to in this case. We'll just say it's 1. And our y-intercept, there's also 1. And one thing we're going to learn with equations, the y-intercept is always this number that's by itself. So in this case, we'd say our y-intercept is at y equals 2. Once again, it has no turning points, and the end behavior will be 1 up and 1 down. So for example, you can see in this case, we're starting, if we go from left to right, we're starting down at the bottom quadrant and we're going up to the top right quadrant. But if we did a graph of, let's suppose we did a different equation, if I gave you y equals negative 2x minus 3, that one would be a graph that goes like that. So it's going to be a negative slope. So in this case, the left one would be up, the bottom one would be down. But you get the idea that it'll always go one up, one down, no matter what. Our next graph we're going to look at is a quadratic. So you guys would have done these in grade 11. And a quadratic is when we get an equation that has an x squared involved. So let's just do a simple one like y equals x squared minus 4. So if we were to graph this one, we would get a U-shaped graph that crosses at negative 4. So in this case, same kind of things apply. Our degree, we would say, is 2 because of the x squared. Our domain, just like before, any real number. Our range is a little bit different this time because our graph never goes below negative 4. So our range, we would say, is greater than or equal to negative 4. So the range is a little bit different with quadratics. And x-intercepts, in this case we've got 2 x-intercepts, so we could find them. But we're also going to see other possibilities for quadratics. You know, it's possible I could draw the graph upside down, something like that, so that we'd have 0 intercepts. But it's also possible I could draw it so that it just touches in one spot only. So that would give me 1 x-intercept. So with a quadratic, you'll have up to the degree. So first degree, we have 1 x-intercept. Second degree, we're going to have 0, 1, or 2. So it could change depending on the question. And in this case, our y-intercept, again, we have 1, and it's going to be that negative 4. And our ends will be either both up or both down, just like we did for a constant. Okay, so either the pointing up or the pointing down. They're either one or the other. But this is the first time we actually do have a turning point. So a turning point for a quadratic is either the max or the minimum. So for our original graph, if we look at the way I sketched it out, we have a minimum at the point negative 4. So it's where our graph turns, it's going down, it turns and goes back up. So in this case, we had a minimum. And there's only one of them. So a quadratic, you'll always just get one. And then our last type of equation is when we have a cubic function. And a cubic function is when we get something that has x cubed. So it'll be something like x cubed plus 3x squared plus 2x minus 1 or something like that. And if we graph this one, we're going to get a graph. We get a graph that does something like this. Okay, so with a cubic, it's sort of like two quadratics put side by side, where it kind of goes up, then it makes like an S turn and keeps on going. So in this case, our degree is 3 because of that x to the power of 3. Our domain and range, just like a linear line, it's kind of like, imagine this graph being just like a regular straight line. The only thing we're doing is we're sort of making a little bend in the middle. So our domain and range will be the exact same thing as for a straight line, which would be any real number for both. And then we have our x-intercepts. So just like we did for quadratics, we had a degree of 2, we could have 0, 1, or 2. When we do cubics, we're going to get 1, 2, or 3. We can have up to 3. So the one that I've got drawn here, we only have one x-intercept. But we could also draw it so it crosses in 3 spots, or we could also draw it where it'll cross just in 2. So you'll have any of those 3 possibilities, but at most you'll ever have is 3 x-intercepts. Y-intercept, still just the 1, and in this case it'll be that number again, so it'll be -1 for this equation. And our ends will be one up and one down again, just like we did for a straight line. And just like we did for quadratics, it'll have 2 turning points, up to 2. So you can see the black one that I've drawn, we had one max and one min. Okay, it's also possible, depending on how you draw the equation, that it could have none, and it's a rare case. And when you have none, your graph basically makes sort of just a slight S-turn, and it doesn't actually make a maximum or a minimum. And that's it. So that's it for polynomial. So constant has degree 0, linear degree 1, quadratic degree 2, and cubic degree 3. And lots of it will just be plugging things in on your calculator and calculating those values. On your calculator, if you need to find them, let's just go through a few steps. So on your calculator, once you have your graph, if it's asking you to calculate certain things, you want to go to second calc, which is above the trace button, and then there's 4 different choices. The first one is value, and that one works good for y-intercept or any other x. So what you do is you just type in x equals whatever number you want, and it'll give you the corresponding y value. Okay, so that one works pretty good. The number 2 on the list is 0, and we use that one for x-intercepts. Okay, so if they're asking what are the x-intercepts, the only thing you got to be careful with that one is if you're looking for this, suppose that x-intercept, what you want to do is you have to go move your cursor somewhere to the left. So when they mean left, they mean if you're drawing it from left to right. So pick a point left of the intersection, and then pick one right of the intersection, hit enter a couple of times, and it'll give you that location. So you'll have to do that for both. Number 3 and 4 both work the same. They're for calculating the turning points. So if you're looking for the max or min, it'll help you figure out those coordinates. So on a graph, let's suppose we do a cubic, and I was looking for this maximum here. You do exactly like you do for these finding the x-intercepts. You just got to go left and right of that peak, hit enter, and it'll give it to you. So those are the best ways to solve. The one that doesn't show up on your calculator, which is too bad, is you can't plug in a y value and give you the corresponding x. Like number 1, you can put in any x coordinate, and it gives you the y, but it doesn't work backwards. But what we can do for that one is use the intersect. It's sort of a cheating way of doing it. So it's used to find y when they give you an x value. Or sorry, I got that backwards. It's used to find x when y is given. Okay, so what you do in that case is, let's suppose we have a graph. Let's do a quadratic graph, something like that. And if my question is, what is the x going to be when y equals 2? So what you want to do is you graph a new line. So you do the original. So let's suppose I gave you x squared minus 2x. Let's do, minus 2x minus 2. That might be something like the graph I got there. And let's suppose I want to say, what is the x going to be, or what is the y going to be when x is, what is the x going to be when y equals 5? So then you just draw a second equation on your calculator. Y equals 5, it'll give you a horizontal line. Then on your calculator, go to second calc intersect and move your cursor to either of those intersection points, hit enter, and it'll give you that coordinate. So it's sort of like number 1, except you have to draw the line, find the intersection point, and then you can go backwards to find whatever the x coordinates are. And that's all.